The line from S, which is the focus of the parabola x squared equals 4ay, meets the normal at P at right angles in Q. If ON is the ordinate of P, show that SQ squared equals ON multiplied by SP. Okay, so this is a parametrics question. The best thing to do is to draw a diagram and see what's going on. So I've already started the diagram here. I have my parabola. Here's my focus S. This is the normal at the point P. And the line from S to the normal at P, of course we're referring to the perpendicular line, meets it at Q. So this is the point Q. If ON is the ordinate of P, show that SQ squared equals ON multiplied by SP. So what does it mean by ON being the ordinate of P? Well, the ordinate is just referring to the y value of the point P. So that means that if I drew a horizontal line here, this is the point N. So here I have from my origin ON. So this is the distance ON. And what about SP? Well, SP is just this distance, joining S to P. Okay, so let's go ahead and work out or prove this. So we're going to start on the right hand side. And the reason we're going to do that is because I can see that there are easy values that we can pick off here. Now, the reason I say that is because what's ON? ON is from here to here, and that is a vertical distance, and vertical distances are easy to calculate. So ON, well, that's just the distance from the origin to the point N. Now the point N has coordinates of, well, let's see, I'm on the y-axis, so the x-coordinate is 0, and if I've moved horizontally across from P, so we have the same y-coordinate, so this is the point 0, AP squared. So therefore the distance ON should be AP squared minus 0, because I'm just subtracting the y values of O and N, and that is obviously AP squared. So I've got ON. Now what about SP? Well, there are a few ways that we can do this, but I think the easiest way is usually the most overlooked way. Now what are we dealing with? We're dealing with a parabola. Now think back to what the definition of a parabola is. A parabola is defined as the locus of all points which are equidistant from a point, which is S, or the focus, and a directrix, a line which is called the directrix. So this distance, SP, if P lies on the parabola, the distance SP should always be the same as the distance from P to the directrix. Let me call this point M. So I can say, by the definition of a parabola, I have that SP is equal to PM. Okay? And now, why is that helpful to me? Well, what's PM? PM is another vertical distance, and that is also easy to work out. So it's going to come from that distance in there plus this distance here. So that's a distance of A. That's a distance clearly of AP squared. And so SP is equal to A plus AP squared, which is A into P squared plus 1. Alright, so what do I have? I have ON times SP equals AP squared multiplied by A into P squared plus 1. So that's A squared, P squared into P squared plus 1. And that is my right-hand side of this statement. Now, what do I have to do? I have to try and prove that SQ squared is equal to this value. So what is SQ? SQ is the distance from a point, which is the focus, and I know the coordinates of the focus, to the normal. Now, in previous videos, we've seen what the equation of the normal is, and I'm not going to prove it in this video. If you are unsure of that, go back and have a look at that video. But the equation of the normal at the point P is given by x plus py equals AP cubed, sorry, plus 2AP. And now let me move this over onto one side. X plus PY minus AP cubed plus 2AP equals 0. Okay, now this is of the form AX plus BY plus C equals 0. That's good, because now I can go ahead and use my perpendicular distance formula. Alright, so let's just recall what that is. The perpendicular distance from a point whose coordinates I know to a line who's of this form is the absolute value of A, X1, plus B, Y1, plus C, divided by the square root of what? Of A squared plus B squared. So applying that formula to my situation here, I have that the distance SQ is equal to, now what's my X1, Y1? Well, the point S is 0, A, and so here I have my X1, here's my Y1, and now I'm going to simply substitute the corresponding values into this formula. A is equal to 1, X1 is equal to 0, so this is 1 times 0, which is 0, plus B is P, Y1 is A, plus C. C is negative of AP cubed plus 2AP. So minus AP cubed plus 2AP. And remember, I take the absolute value of that. Don't forget that. Dividing by the square root of A squared plus B squared is the square root of 1 plus P squared. Alright, here I'll have PA minus 2AP. So I'll be left with negative AP. Here I have negative AP cubed. Take the absolute value of that. Divide by 1 plus P squared. Alright, I can get rid of a negative 1 here. I can factor out, in fact, I'll factor out a negative AP. And I'll be left with this, 1 plus P squared divided by the square root of 1 plus P squared. Now this negative will vanish because I have absolute values, and I'll have AP times 1 plus P squared divided by the square root of 1 plus P of the square root of 1 plus P squared, and that gives us 1 plus P squared, and we take the square root of that. So that's like having a power of 1 divided by a power of a half, and that gives me a power of a half. Okay, so that's what SQ is equal to. So SQ squared is simply just squaring this expression. Squaring that, and I have A squared, P squared, into 1 plus P squared, which is equal to ON multiplied by SP. And that is what we needed to prove, that SQ squared was equal to ON multiplied by SP. So we can write QED. And that's it.